Good morning, one and all. Myself, Sreevani, working as an assistant professor in the Department of Electronics and Communication Engineering in Institute of Aeronautical Engineering, Dundigal, Hyderabad. So, in this lecture, we are going to learn about how the outcome-based OBE is to be considered in the electromagnetic waves and transmission lines. So, in this particularly, what actually course outcome and program outcomes, how the PEOs and POs as well as POs, COs relations, and how the articulation matrix are to be written for this particular course, we will learn in this particular session. What is outcome based education? So, OBE is a student centric teaching and learning methodology in which the course delivery, assessment, or plan to achieve stated objectives and outcomes. So, each and every course will have their own objectives and outcomes in order to achieve such objectives and outcomes. Basically, it is a OBE is a student centric teaching and learning methodology in which the course delivery, assessment, are particularly planned to achieve the stated objectives and the outcomes. It focuses on measuring student performance. How much knowledge is to be gained by the student at the end of this particular course is to be measured based upon this particular one, outcome based education. Then OBE is all about feedback and outcomes of institutions try to bring changes to the curriculum by dynamically adapting to the requirements of the different stakeholders and recruiters. Its true stakeholders means students, parents, all the different staff members which are involved in that particular institutions. Next, why OBE? In order to get international recognition for the respective institutions and the global employment opportunities, we need OBE. Then better visibility and reputation of the technical institution need to be increased with the help of this OBE. Then more employable and innovative graduates with the professional and soft skills, social responsibility and ethics. To get all these qualities, we need OBE. Then improving the involvement of all the stakeholders, we need OBE. With the help of this OBE, by enabling graduates to excel in their particular professions, means like respective branches. Then by preparing graduates for the leadership positions and making them aware of the opportunities in the technology development, we need OBE. These many advantages are there with the outcome based education. Next, what is the fundamental differences between traditional education and the outcome based education? So in the traditional education, grades or ranks based assessment will be there, and grades are derived from points on activities, assignments, exams, etc. And judgment methods are shaped from the previous results, and only summative assessment is to be considered in traditional education, and no assess feedback improve loop in the traditional education. When it comes to the outcome based education, desired outcome based assessment. The outcome means the goals which are set by the students or faculty or institution are to be achieved based upon this outcome based education. And completion of education implies the learner has achieved a set goals. And judgment methods are shaped from continuous evaluation. From starting to ending, from the first year onwards, then after completion of 4 years, means the evaluation must be continuous. Then both formative and summative assessments are to be considered. The presence of assess feedback improve loop is there in the outcome based education. These many advantages are there over when compared with the traditional with OBE. Hence, each and every institution must and should follow this OBE. Next, what are the key aspects of the OBE, outcome based education? So, a course is defined as a theory. The first key aspect in this OBE is a course. Means a course is defined as a theory or practical or theory come practical subject student in a studied in a particular semester. For example, if I am dealing the electromagnetic waves and transmission lines. So this is one particular course, theory course. With this course, the in that particular semester, the students are going to study. Like EMTL means inner programs, means like inner electronics and communication departments, EMTL, then signals and systems, then PTSP, then analog communications, digital communications. These are all some of the examples for the courses. Course is nothing but it is a theory subject or practical subject. Sometimes the both can be considered as a single subject and which is to be studied in a particular semester. Then course outcome, how it is to be written, means course outcome is a formal statement of what students are expected to learn in a particular course. When creating course outcomes, remember that the outcomes should clearly state that students will do or produce to determine and or demonstrate their learning. Right? How this course outcome need to be considered. When we are writing this course outcome, what are the key points we need to keep in mind to write that particular course outcomes? We will come to know. So, course learning outcome statements refer to the specific knowledge or practical skills or areas of professional development and attitudes and higher order thinking skills, etc., are to be considered in this particular course outcome. Then, what do you mean by program? It is also one of the key aspects in the outcome based education. Program is defined as the specialization or discipline of a degree. Different branches are to be considered. It's an example for program like ECE, then EEE, then CSE. These are all the different examples for the programs. Right? Program is nothing but it is a branch or a specialization or a discipline of that a particular degree course. It is the interconnected arrangement of courses, co-curricular and extracurricular activities to accomplish predetermined objects leading to the awarding of a degree. Then program educational objectives. PEOs should be defined by the head of the department in consultation with the faculty members. Means the faculty and heads are to be sitting together then to define this objectives called program educational objectives. Then PEOs are a promise by the department to the aspiring students about what they will achieve once they join into the particular program. Next, some of the key aspects are again PEOs and PSOs, where PEOs are about professional and career accomplishment after 4 to 5 years of graduation. Then PEOs can be written from different perspectives like career, technical competency, and behavior. 3 to 5 PEOs are recommended particularly for the programs. Next, program specific outcomes. These are what the student should be able to do at the time of graduation with reference to a specific discipline. And usually there are 2 to 4 PSOs for a program. So in related to the R regulation, now we are now in a UG 20 regulation. In our particular program, means like electronics and communication branch, we have a 3 program specific outcomes. One is related to the VLSI stream and another one is embedded stream and followed by next one is communication stream. Next, program outcomes. So a program learning outcome is borrowed in scope and be able to do at the end of the program. And POs are to be in line with the graduate attributes as specified in the Washington Accord. And POs are to be specific, measurable, and achievable. And NBA has defined 12 POs, and you need not define those POs by yourself, and it is common for all the institutions in India. We should follow all these 12 program outcomes. So, now this is about the fundamentals related to outcome based education. Now, how this outcome based education is means OBE is to be implemented in my particular course as electromagnetic waves and transmission lines. Firstly, we have considered here the course overview of the electromagnetic waves and transmission lines. This course overview is to be given by here. There are three main statements are there. In the first statement means electromagnetic waves and the transmission lines gives the necessary information about the formation of magnetic fields when electric current flows and structures to conduct electromagnetic waves. Basically, in this two different topics are to be studied. One is related to the electromagnetic waves, and the next one is with a physical connection that is said to be transmission lines. It covers the fundamental concepts of electromagnetic wave theory and introduces the basic laws of electromagnetic fields, time varying Maxwell's equations. There are four Maxwell's equations are to be there, wave propagation and transmission lines. These are the main topics which is to be covered in this particular course, that is electromagnetic waves and the transmission lines. And it provides a platform for advanced courses such as antennas and wave propagation, microwave engineering, transmission via wired links, and optical fiber link networks. Right? It is the fundamental subject. Then, with this, the forthcoming semesters are some of the subjects are to be studied as antennas and wave propagation, microwave engineering, radar engineering, and all the subjects related to transmission via wired as well as the wireless. Right? This is about the course overview related to this electromagnetic waves and transmission lines. Next one. There are three course objectives have written for this electromagnetic waves and transmission lines. The first one, the basic concepts required to understand various engineering applications involving electromagnetic fields. This is the first course objective to the electromagnetic waves and transmission lines. And the second one is the wave propagation characteristics. Students will also be able to learn the wave propagation characteristics of electromagnetic wave in bounded and unbounded media. If you are considering the propagation means wave analyzation is about for the bounded regions we have to consider only one particular region, and unbounded means if the wave is to be propagating between two media, then it is to be analyzed with respect to the boundary conditions. Next, students will also be able to learn the basic theory of transmission lines and then appropriate tools like Smith chart to analyze transmission lines. Right? So, with the help of the Smith chart, we can calculate input impedance, reflection coefficient, and standing wave ratios of the particular transmission lines. These are the three course objectives of this electromagnetic waves and the transmission lines. Next, course outcomes. There are 6 course outcomes I have written for this electromagnetic waves and transmission lines. First, CO1. Describe fundamental laws. Those are related to the electrostatic fields, deals with Coulomb's law and Gauss law to evaluate the field intensity and flux density of continuous charge distributions. This will comes under Bloom's level of understand level, right? So the basic electrostatic fields equations, laws which are governing in electrostatic fields like Coulomb's law and Gauss law. Based upon this, we will evaluate electric field intensity and electric flux densities of continuous charge distributions. Second CO, that is demonstrate Biot-Savart's law and Appier's circuit law to determine forces due to the magnetic fields. The first CO is related to electrostatic fields and the next one is for the magnetostatic fields. Two are to be defined under understand level, the second Bloom's level. Next is apply Maxwell's equations and their applications to time varying fields and boundary conditions. Right? So for the boundary means to find the Maxwell's equations in order to analyze boundary conditions between two dielectric media or different media, homogeneous media or isotropic media, we have to apply the Maxwell's equations. And this will comes under apply level. Next one, CO4. Construct the wave equations for both conducting and dielectric media to derive the relation between electric and magnetic field intensities. Coming to this one, and this is for wave propagation. With this, we will construct wave equations and we can relate electric field intensity vector E with the magnetic field intensity vector, and we can derive the relations between E and H in normal case as well as phasor form. And this will also comes under apply. Why? Because we need to apply some Maxwell's equations to derive the relation between E and H. Then next one, understand the propagation of electromagnetic waves through different media using the concept of uniform plane waves. So the first one case we have derived the wave relations, wave equations under that the electric field intensity vector and magnetic field intensity vectors are how those two are to be related is to be comes under the fourth CO. Coming to here, if the wave is to or if the wave is to be propagating between two media, reflections are occur and refractions are occur, and those are to be considered in this particular CO. Next, CO6 is make use of the Smith chart as a graphical tool to solve impedance matching issues in the transmission lines. So this is for the transmission lines, and to find reflection coefficient and standing wave ratios with the help of graphs, we use the chart called Smith chart. With this, we will find some of the impedance matching issues which are involved in the transmission lines are to be evaluated. So we have to apply some formulas and all. Then we will consider here Bloom's level as under apply level. Next is program outcomes. There are 12 program outcomes are there. PO1 is engineering knowledge and PO2 is problem analysis and PO3 is design or development of solutions and PO4 is conduct investigations of complex problems and PO5 is modern tool usage and the engineer and the society as PO6 and environment and sustainability as PO7 and ethics is for PO8 and in PO9 individual and teamwork and in the PO10 communication and PO11 is project management and finance and PO12 is lifelong learning. Out of all these 12 program outcomes, I used to consider my in my course, particularly electromagnetic waves and transmission lines. I used the first three COs as engineering knowledge and problem analysis, and some of the cases design or development of solutions. Along with this first three, I've considered related to this. My course is completely based upon the communication one. Then I'm mapping the PO10 also for my course. So these are all the program outcomes mappings with a proficiency assessed, how it is to be attested. With a SCAE level as well as a CE level and AAT's case, it is to be applicable. PO1, I am considering engineering knowledge, means in order to find some electric field intensities, magnetic field intensity vectors, whatever the relations we have evaluated in electric fields as well as the magnetic fields, we need to apply some mathematics knowledge. Engineering level fundamentals. That's why I'm considering my first one as engineering one, and the strength is to be considered. That is maximum is to be analytical one. That's why I have given this one as the 3. Then coming to the problem analysis. The subject is somewhat analytical one. That's why I have considered this one as problem analysis. As PO2 is also mapping. So we need to identify which formula is to be given, which is the source is given, which type of objects are given. Based upon that, I have to formulate and I have to review the formulas and all, and I have to analyze that particular. That's why, and I need to apply some principles of mathematics and all, and I use the problem analysis. And the third one is design or development of solutions. Means I want to design the Smith chart and all. We use some complex calculations and all. That's why the third one also I'm considering. And PO10 means this complete subject is based upon the communication one. Hence, I'm considering the PO10 is also for my mapping case. I'm considering this program outcome. PO1, 2, 3 and 10 I have mapped for my electromagnetic waves and transmission lines. Next one, justification. How that particular course outcome is to be mapped with the program outcomes and PSOs, and how the number of competencies means how many keywords I have considered in this particular. Depending upon that, I have given the strength is to be as mapped here. The first one, PO1, demonstrate the fundamental laws of static electric fields to evaluate the field intensity and the flux density of various charge distributions by applying the knowledge of the mathematics, science, and engineering fundamentals. So here I am considering three keywords. Hence, I have given here it as the value as 3. Then similarly, next one, identify and formulate the fundamental laws of static electric fields to evaluate the field intensity and flux density of various charge distributions by using principles of mathematics and engineering sciences. Identify and formulate along with the principles of mathematics and engineering sciences. I have taken 4 keywords. Based upon that, I have given here 4 as my strength. Next one for PO10. Describe the fundamental laws of electrostatic fields by giving effective presentations and take clear instructions to evaluate the field intensity and flux density of continuous charge distributions. Here I am using 2 keywords as giving effective presentations and take clear instructions to evaluate such field intensity and flux densities. Then for PO10, I have mapped for my course outcome 1. Similarly, I have written remaining also in the CO1 to CO6 as like this. Next, the total count of key competencies for CO, PO or PSO mapping. So whatever I have written in the previous justification table, then I have tabled all those values here. CO1 is mapped to 3 and 3 keywords I have used, and for PO2 it is 4. Like that, all the CO1 to CO6 are to be evaluated, and here this PO10 I have considered, and it will be related to the communication one, and the least case I have considered 2 keywords as for this, and for PSO3 it is related to the HFSS, high frequency structure simulator. With the help of this advanced type of communications like antennas are to be implemented in this. That's why PSO3 I have chosen, and whatever the key competencies which I have considered for the justification case, and I'm mapping for here, and the count can be considered as like this. Next one is percentage of key competencies for. Depending upon the weights of the factors which is given for the PO1 to PO8, and whatever the keywords I have used over there, depending upon that, the percentage has to be calculated as like this. Right? So, next one, course articulation matrix. This one is the important one based upon the strength I have used for that, and based upon the justification I have considered over here. This is the table. Depending upon this, have considered over there is my articulation matrix as C. See, CO1 it is to be mapped as for 3 means. Now to write this articulation matrix, we should follow some that key attributes and all. That is, the range will be, if my percentage range will be from here, means it is from if the percentage is between 0 to 5%, 5% no correlation, and 5 to 40% it will be mapped to be as 1, and 40 to 60% it will be considered as 2, and 60 to 100% it will be strongly agreed or completely agreed, hence it is to be considered as depending upon the I've given the strengths has to be as 3 and 2 for CO1 and PO1 2, as well as CO2 is given by, means the complete CO1 to CO6 I have mapped here 3 according to that. Why? Because here I have written, see, CO1 to PO1 mapping case, I have considered the fundamental one as I've taken here as by applying the fundamental knowledges which are involved in the mathematics and sciences, as well as the engineering fundamentals case, that is completely related to my subject as This electromagnetic waves and transmission lines is a completely analytical one. Hence, I'm considering my strength is to be as 3. Right? It is to be completely matched perfectly. That's why I'm given that one as 3. And coming to the next one, in the PO2 case, identify and formulate. I have to identify whatever the values are to be given, and I have to apply some formulas to calculate whether the given one is a problem type, or I have to analyze that particular. Then to apply, to write the formulas and to solve, I need to write some of the principles of mathematics and engineering sciences. Based upon this, I have given the value as to be 4. Then in the communications case, I have considered only 2 keywords as giving effective presentations and take clear instructions to evaluate the field intensity and the flux densities of this particular charge distributions. Why? Because we are considering here CO1 means the CO1 is applicable for the electrostatic fields. So depending upon this, if you are considered as weightage is as given as the competences values are to be given as 3, 4, 2 like that. See here, if you observe in the COs, see the first CO is related to the electrostatic fields, and second one is for magnetostatic fields, and third one is about Maxwell's equations as well as the boundary conditions, and for 4 is to be wave equations, and it is to be bounded for only one particular, and CO5 is if the wave is to be propagating between two medium, then we have written the wave propagation characteristics case CO5, and CO6 is completely related to the transmission lines. So, to find all the characteristics of the Smith chart, like reflection coefficient, standing wave ratios, and as well as the input impedances of the and some impedance matching issues which are involved on the transmission lines, we use the course outcome 6. Depending upon all the values I have tabulated, this final one as articulation matrix as like this. Now, how I have added all these total to get total and average values to be obtained in this course articulation matrix is, so by adding all CO1 to CO6, I am getting here total values like this. Then the first case, all 6 are to be mapped, hence it is 16, and 2 are to be 6 is to be obtained as 12. And here I am adding 2 only, 2 plus 1 as 3. And for PO10 communications wise, I am using all such as 1s and 6, and PSO3 is to be mapped for CO3, 5 and 6, and the CO3 is for Maxwell's equations and your reflections case of uniform plane waves, and transmission lines purpose. I am considering this HFSS tool usage of this PSO3. Then depending upon that, this average is to be calculated. Right? So this is about my how OBE is to be applicable in the is to be considered in my particular course as electromagnetic waves and transmission lines. Right? So why OBE? What are the uses of OBE, and what are the key aspects which are involved in the OBE? Then how 12 COs are to be considered? Depending upon that, in my particular subject, I have considered 4 program outcomes, PO1, 2, 3 as well as PO10, and based upon that I have written some justification depending upon the key attributes which are involved in the each and every program outcomes have mapped with the course outcomes, and based upon that I have obtained that one course attribution matrix. So thank you.
Like, share and subscribe. Hit the bell icon for more updates.